Hello, I am Alia Izzat-Gasti. Today's lesson is about getting to know LS HMIs and their application in the ED document. As you know, in addition to inverters, PLCs, and servo systems, the LS brand also produces HMIs. Today we want to get more familiar with the different types of these HMIs. HMI stands for Human-Machine Interface. The Human-Machine Interface, which in actual fact means the essential interface between human operators and various machines, has numerous applications within industry. Typically, an HMI system is connected to a programmable logic controller, and here we have carefully written a sample program directly onto an HMI device. Now, what we are precisely going to do is to demonstrate. We utilize a series of switches, and when we interact with one of these switches on the HMI with our finger, for example, a specific input on the PLC can be activated, or one of the outputs can be activated to perform a certain designated task for us. In fact, these function quite similarly to start and stop push buttons, and we can also effectively use the HMI as a valuable data logger. That is, we can plot a comprehensive graph on the HMI over time and monitor the specific changes of a process in detail over time. And we can also use the HMI as a data logger, meaning that we can plot a graph over time on the HMI and observe the changes of a process over time on the HMI, or by connecting a flash drive to the HMI, we can save process values as an Excel file for later use. This image shows the back of an HMI displaying its parts. This section is for the micro SD card, where you can add one to the HMI and process values you can easily save them. This particular part is directly related to the versatile USB host functionality, where you can actually conveniently add a flash drive, as I previously mentioned, for example, to securely save some important values, or you can also readily add a computer mouse and effectively use the mouse to precisely move the cursor on the HMI unit itself. This subsequent section is specifically about the protective battery cover, because the HMI unit itself, it has an internal replaceable battery accessible by removing the cover. DIP switches allow configuration per the HMI manual. This relates to the device's own dedicated power supply, which can be either a 24-volt direct current DC or a more extensive range of 110 to 220 volts alternating current AC. This particular section is also directly related to the actual human-machine interface, his HMI terminals, and this specific part is designated for the essential Ethernet network port, which you can effectively utilize for various Ethernet network connections and communications. This section is a connector related to the RS422 or RS485 serial port, which is actually RS422, but we can convert it to RS485. There's also another port here which is for our COM1 and COM2, supporting both RS232 and RS485. Based on these essential ports that I have just thoroughly introduced to you, we can effectively connect each and every one of these distinct ports to a specific device. For example, we can conveniently connect an HMI, which is a human-machine interface, to a PLC, a programmable logic controller, via the reliable RS232 serial port. Alternatively, we can simultaneously establish a connection to another PLC through the versatile Ethernet port, and additionally, we can also utilize the robust RS485 port for further connectivity options. For example, we can connect to an inverter. All of these can happen simultaneously, meaning we can use an HMI at the same time through the RS232 serial port, the Ethernet port, and its RS485 port, and connect it to different devices. Now, in the following, I will mention a few applications of HMIs in industry. We will get thoroughly familiar with them. One of the most common and practical applications of HMIs is effectively networking several inverters with a single centralized HMI. If all our inverters are exclusively of the LS brand, we can conveniently utilize the dedicated LS bus network, which specifically means we employ the robust RS485 serial port, along with the proprietary LS bus protocol. This advanced setup reliably allows us to seamlessly connect and manage several inverters simultaneously, providing comprehensive control and monitoring capabilities. We can be networked with a single dedicated HMI, or alternatively, we can connect several individual HMIs to an LS PLC through the efficient LS bus communication protocol. Now, this particular application is most commonly and effectively used in comprehensive lighting systems. For example, just imagine a large multi-story building. On each and every floor, we can conveniently use a dedicated HMI and precisely control the entire lighting setup of that specific floor with its invaluable help and assistance. All of these advanced HMI units can be seamlessly connected to a single programmable logic controller, or PLC, via the efficient LS bus communication protocol. Another significant and practical application of these versatile HMIs involves networking several distinct PLCs with a single centralized HMI unit. In such scenarios, we can effectively utilize a high-speed Ethernet network connection to substantially increase our overall working speed and efficiently connect multiple individual PLCs to one comprehensive HMI system. We can network PLCs together with a single HMI. Another use case for HMIs is that besides PLCs and inverters, we can also connect the HMI to other devices via the RS485 serial port using the Modbus RTU protocol. Of course, this depends on whether those devices also have the RS485 serial port with the Modbus RTU protocol, which is also widely used in industry. Now, LS HMIs can be divided into two categories. The first category is the EXP2 series, and the second category is the IXP2 series. We'll get more familiar with these two series as we go on. So it's showing us the dimensional chart of the HMIs and is comparing these two series in terms of their dimensions. In the EXP2 series, we have sizes ranging from 4 inches, 5 inches, 7 inches, and 10 inches. In the IXP2 series, we have models in 8 inches, 10 inches, 12 inches, and 15 inches. Now, depending on these HMIs can be used as needed. Let's look at how to read EXP2 series model numbers. After EXP2, if the number is 04, it's 4.6 inches. If 05, it's 5.6 inches. If it is 07, which specifically indicates it's exactly 7 inches, and if it is precisely 10, meaning it's 10.1 inches diagonally. This particular numerical value is clearly displayed here on the screen. The next number specifically refers to the operating system type or version. If it is 0, which signifies the Windows CE 7 Core Edition, and if it is 1, which then indicates the Windows CE 7 Pro version. Furthermore, the subsequent number in the sequence is directly related to the network ports of our HMI. If the number is 0, it means it has serial ports RS232, RS485, RS422, and Ethernet network on board. But if it's 1, in addition to all the above mentioned features, it also has a micro SD slot, meaning we can add a memory card to our HMI. And if this number is 2, it means that it only has the serial ports RS232, RS485, and RS422. So in this case, it no longer has Ethernet network or micro SD. The next letter, which appears separately in this series, indicates that the power supply for our HMI is 24 volts. It's 24 volts DC, and this last letter indicates the IP rating of our device, which in this case is IP66. Now in the next models, which are the IXP2 series, the number that appears here indicates the dimensions of our HMI. If it's 08, it means 8 and 14. All of these, if it's 10, that means it's 10.2 inches. If it's 12, that means it's 12.1 inches. And finally, if it's 15, it means our HMI is 15 inches. The next number that appears here indicates the OS type of our HMI. If the number is 0, it means it's Windows CE 7 standard. And if it's 1, it means it's Windows CE 7 Pro. Well, the next number that prominently appears here clearly indicates the specific network ports of our advanced HMI. That means in the IXP2 HMIs, There are indeed RS-232 and RS-422 serial communication ports, which can also be very easily and conveniently converted to RS-485, as well as a high-speed fast Ethernet network port. Now, the next important letter. This letter indicates the device's power supply. If it's the letter A, it means our device can use AC power, supporting a voltage range from 100 to 240 volts AC. If it's the letter D, it means the voltage is DC and it can support anywhere from 12 to 28.8 volts, which is a DC voltage. And this very last letter, if it's EXP, it specifically means export products. If it's EX, it clearly indicates that our HMI in fact possesses the explosion-proof standard, meaning this particular HMI is indeed explosion-proof and can be safely utilized in environments where the stringent X standard is absolutely required, meaning our HMI comprehensively meets that important standard, so that it is completely explosion-proof and we can safely and effectively use it. All these advanced human-machine interfaces, or HMIs, that I just thoroughly introduced to you, specifically both the robust EXP2 series and the innovative IXP2 series, consistently use the powerful XP Builder software for all their programming needs. You can conveniently download this highly efficient software for free directly from the official LS Electric website. In summary, these HMIs offer exceptional performance and safety features. Next, explore software. Thanks.